Well, good morning. This is 11:38. I'm late minutes, getting 8 minutes late getting started. Sorry about that, but I had my last class went over just a little bit, and then I had two people stop and ask questions, and by the time we got those done, I barely had time to get down to my office, exchange books, and get back up here. So sorry that we're getting started late, but I think one person has been in the room but no longer is in the room. Hopefully he'll be back. But I'm in here all by myself right now. So we'll start from where we left off last time, which according to my mark was right at the beginning of Kirchhoff's laws. We had talked about networks, and there was a problem that we set up but didn't have time to finish. And I said if y'all had any problems with it, bring them to class and we would work that out, but nobody's here to bring it, so I'll move on into Kirchhoff's law. Laws, more than one. Okay, an electrical network is another type of network where the analysis is commonly applied, but this is not just going in and coming out like we were seeing before. Part of it is like that. For instance, the current part is a lot like that. All the current flowing into a junction must flow out of a junction. So in this way, that part of it is a lot like the networks we were just looking at. However, those would not make good electrical networks because they'd be shorting out like crazy because you have too many pathways that connect. So your electrical circuits have to follow a bit more structure than what the last ones did. But that just gives you one. The current flowing into a junction must flow out of it. That's like we did before. But now we also have the sum of the products, I times R, where I is the current, R is the resistance, I times R is voltage. And what you have basically, somewhere you have a voltage source, it's going to be a positive voltage, and every resistance is then going to be a voltage drop, and the amount of voltage drop is I times R. So the catch to this, the sum of the voltages around any closed path, sometimes called loops, is equal to the total voltage in the path. In other words, if you sum them up around there, they've got to equal zero. If you have positive voltage being positive and a voltage drop being negative, then they've got to add to zero. Okay? Now, a little bit on nomenclature here. This is a symbol. Let me get my pen set up. A symbol like this, and I'm going to try to draw it the same way they do. I usually draw it the other way, but that is a battery. This would be the positive side, that would be the negative side. Okay, so if you went this way around a circuit loop, that would be a plus V if that was the voltage from the battery. Okay, if you happen to be going that way, that would be a minus V because you're going from high to low. So depends on the path that you're taking, which way you're going. You have to choose a path and then be consistent when you're going through that path. Okay. Now, other things to note here. The symbology for a resistor is a jagged line like that. And the resistance is measured in ohms. So that's the symbol for resistance. Current is usually indicated, let's say this was saying as this, that would be I in, say, that direction or whatever direction you might think it's going. Let me draw it more correctly for what we've got here. According to this voltage, my guess would be the current is going in that way because it goes from low, it goes from high to low, so the current would be in that direction. And current is measured in amps. All resistances, the symbol is R. The unit is omega. The symbol for current is I. Its unit is amps. And the symbol for voltage, let's see what your book, it doesn't say what it is. But quite often is used as the same symbol. V for volts, and V is also the unit for voltage. Okay. So let's do a fairly simple circuit, and I think most of you have had physics, so you've probably already done these, maybe ad infinitum, sorry, I didn't quite say it right. Here we have a circuit, and I'm going to start with the 7 volts on top. And they put the 7 volts in this direction, 7 volts that way. This is minus side, that's the plus side. Okay? Now, to the left of this 7 volts, you run into a resistor. And that is R1 is 3 ohms. Okay? Now you have a current going here. We're going to call that I1. And that's usually what we're looking for, the current. Okay? This comes down to a juncture. Okay? They're naming that number 1. And leaving that juncture is I2. I1 goes through resistors. This is still I1 here. And we're just arbitrarily putting it that direction. And here's R2 down here. And this happens to be 2 ohms, a 2 ohm resistor. Okay? And it goes over here to another juncture they're calling 2. But also leaving junction 1 is a leg of the circuit, and it goes through R3 and hits another power supply or voltage, and that is 8 volts. And again, minus the plus here, so this is 8 volts in that direction. So it's 7 volts in this direction, 8 volts in that direction. This was, by the way, R3, which I think they said was 4 ohms. And because this is a different current here, but fed by this 8-volt battery, I'm guessing this current is doing here. This will be I3. Okay? So it looks like to me I2 has to be flowing outward. Okay, it's got to be, because I1 and I3 both indicate they're going into junction 1, so I2 must be coming out of it. All right. Now, if you put one of the currents going in the wrong direction, don't sweat it. At the end, you'll have a negative current there, and then you just switch the arrow and you got the positive current. Okay, so Kirchhoff's first law was the currents flowing into a junction equal to current flowing out of the junction. So basically that says that I1 is flowing in minus I2 flowing out plus I3 flowing in equals 0, because the current, the other way to say that I1 plus I3 is equal to I2. That's pretty obvious here. But since these are what you're looking for, it says determine the currents, I1, I2, and I3 for that network. That's what you're looking for, so we want those to be the variables here. Okay? Now, if you tried to do juncture 2 here, you would see that I1 is leaving this, because that's the same current throughout that leg. There's no other way to get any other current there. And this I2 would be coming in, and this I3 would be going out. Okay? Well, then you have I1 plus I3 is equal to I2. It's the same thing. So you don't get another current equation out of junction 2. Before, in those others we did, you could get an equation at each junction. Here, these two equations are the same. So you only get one equation from there. So that means you need 2 more equations, because you have 3 currents you're trying to identify. All right, well, what does that mean? You need 2 voltage equations. And because we've assumed that the current is flowing in this direction, let's do that as a loop, and we've assumed the current here is flowing in this direction, so let's use that as a loop. Okay? Now, we know the voltage here, okay? So that's going to be my right-hand side. So let's start at this point right here and go around this circuit in the direction indicated by the arrow inside the circuit. So inside there we have a voltage drop. Well, okay, so what we're going to do is drops on one side of the equation is going to equal supplies on the other side, okay? So we don't have to do plus or minus. So what right here we have 3, because remember the voltage drop across the resistance is I times R. So this is I1 times R1 is the voltage drop across this one. R1 is 3 ohms, so we have 3 I1 plus 2 I2, and get all the way back around here, that's going to have to equal 7 volts. The voltage drop across the first resistor plus the voltage drop across the second resistor has to equal the voltage supplied by the battery, 7 volts. Okay, let's do the second circuit down here. This one we're going the opposite direction, you might say. So let's begin our voyage right here, and there we're following I3, so this will be 4 times I3, because 4 ohm times I3 is the current here, okay? Then you get up here, and it's plus 2 I2, that's the voltage drop across that one, 2 ohms current of I2, and that has to equal, you make it all the way around here, nothing, no other drops until you get to 8. Okay? So these are our 3 equations, 3 unknowns, our 3 currents. You need 3 equations. We got them. Now, did we have to use those loops? No. We actually could have used the loop around like this. Okay? And if we'd have used that loop, I would have started here, and that would have been a 4 I3, and then this would have been a 3 I1. But the question is, to have you got the sign right? We would just assume it's going to be a plus, but then this would have to be a minus 7 here because you're going against the thing. That was a good reason not to choose this one, but you could have chosen it. That would have been minus 7 is equal to 8. In other words, no, I would have said it's equal to minus 7 plus 8, so that would have been a plus 1. That would have been awkward. This is much cleaner, okay? So let's set up our matrix to represent this. 1, minus 1, 1, and 0. 3, 2, 0, 7. 0, 2, 4, 8. All right. Now, just a couple of things. Yeah, I just remembered something. This is the matrix now, representing that system of equations. Now, what you want is a 1 right there, and we got it. But before we do anything else, it would have really been nice for this equation to be up here, wouldn't it? Especially noting you can divide everything by 2, and that makes a 1, 2, 4. Then if you swap them, you already have a 0 where you want it and 1 where you want there. So first thing we're going to do is row 2 exchange with 1/2 row 3. Okay? So the new matrix will be 1 minus 1, 0. going faster than I'm thinking, faster than I'm doing. Okay, 1, 0. And then the new second row is 0, 1, 2, 4. And the new third row is 3, 2, 0, 7. All right. So let's backtrack a moment. We got a 1 where we want it. Next we want that to be a 0 where the 3 is. Well, how do we do that? Going back to the way that that Peyton wanted me to do it, was -3, or whoever, somebody wanted me to do it, -3 row 1 plus row 3, or row 3 minus 3 row 1. It doesn't matter how you do it, but I'll do it that way. So row 1 stays the same, 1 minus 1, 1, 0. Row 2 stays the same, 0, 1, 2, 4. And if my writing will catch up, there it is. And row 3, the new row 3 will be -3 times 1 is -3 plus 3 is 0. All right, Muhammad is here. All right, thank you. Okay, somebody's book is here. I'm guessing it's Peyton, because he usually sits over here. I think that's Mr. Algebra. But I was a couple minutes late. No, this is differential equations. I wonder if you brought the wrong book, realized it, and went back to get the right book. Because I'm pretty sure that wasn't sitting here before. He's in both, so I'm guessing that's who it is, and that's where he usually sat. But I'm glad you're here. He wasn't here when I came, but the book was there. And I just assumed it was linear algebra, but now what I look at it is differential equations. So, we'll see. And you brought lunch, good. Oh, no, I'm just kidding. Okay. Yeah.
It's breakfast, actually.
Oh, breakfast, okay.
To my schedule.
Yeah. I just, in between class, and I had said this earlier, I was a few minutes late getting here, mostly because when my trig class ran over a little bit, I forgot to bring my watch, and they let me go too long. And then after class, 2 students stayed and asked questions, so I had to, deal with both of those questions. And then I finally got down to my office to swap out books, but I was so starving that I ate a granola bar while I was down there, so that took me an extra minute or two to cram that down. Huh? Yeah, no, it wasn't much, but just something. I have lunch down there that I'm going to eat after this class, but I just thought I need something before we get to class. So what we're doing is, have you done Kirchhoff's laws in physics?
Yes.
Okay, so that's what we're doing. So this is nothing new. Probably really hard to follow my writing here, but I'll quickly go over it. What we have is a battery here, okay, 7 volts, then a resistor here of 3 ohms, a junction here at 1, another resistor here at 2 ohms, and then another junction here. Oh, I think I recognize this guy. I've seen him somewhere before.
Somewhere out there. I don't know.
Okay, no, you were here last time, weren't you? Yeah, it was differential equations.
All right.
All right. Have you've had physics 2, right?
I'm taking it now.
Taking now physics 1 or physics 2?
Physics
2. Okay.
Yeah,
Yeah. If you are probably haven't done Kirchhoff's laws yet. Or haven't.
No,
Okay. You'll get there.
At the end of this class, like
At the end of the class.
yeah, it's recorded meal class.
Yeah. Okay. So I probably need to do a little more explanation for you. Should make you listen to it on YouTube, but it won't make a lot of sense unless you know what we're talking about here.
Plus, you like me too much to.
And you're making fun of my writing too. Is that what you said? Okay, I noted. Okay, I marked -7 on your score, daily class score today. Maybe -70. All right. What this is an electrical circuit. Okay, and I'm not even going to name it. It somewhat looks parallelish, but it's rather bizarre. Here we have a 7-volt power supply with the minus on this side, plus on this side, so it's 7 volts in that direction. Okay? Here he is.
Ooh, that looks interesting.
Is that your book? That's your book?
Mine's on the PDF.
Yeah.
Because I thought that was yours.
Someone left a different.
Oh, that was, yeah, it probably was the book, yes. I probably forgot to pack it up. Yeah, I got this class's book on PDF. But
Okay.
I almost donated it, man.
I tell you,
That's right, to me.
oh yeah,
well,
speaking
only
about
like,
books.
there's only like
What's
5
that?
people in this
Speaking
that
about
this
books.
book's even
Yeah.
useful for.
I can't.
You know?
No, I'll
I
give
said,
you the
speaking
receipt.
about books, do you have the code now?
To me, it didn't-
No, not in this class. I haven't checked to see if he sent one yesterday, okay? But I will check tomorrow and see if, I don't think I have any checks today, because I got this class, a half hour for lunch, and then a 4.5-hour class, and then I've got to be somewhere tonight. So I doubt if I'm going to get to it tonight. But tomorrow I hope to have some office hours, and I've got a meeting tomorrow afternoon, but I hope to be able to find out where he is on it, because not only did he not send me book codes for these 2 classes that you're in, 3 other classes he didn't send, and one that he did send, he sent me the wrong one. Yeah, he sent me for my trig class. He sent elementary algebra. Intermediate algebra. So I'm not very impressed with them at all. Okay.
So this is Kirchhoff's current laws?
Yeah. Junction laws or something.
With the parallel circuit?
Kinda. It's a weird one.
I see multiple power sources.
Yes, exactly. That's what makes it weird. But this is a math book, not a physics book. So, okay. So what we have here,
Go easy on physics. There are some people who are not taking it.
this is a circuit, and the 2 parallel lines, one long, one short, that indicates a battery. Think of 2 cells in one cell in a battery, a negative plate and a positive plate. That's what that represents. So that's minus, that's plus. So this is a plus 7 volts going that way. Then you hit a resistor here, and that's a 3 ohm resistor. You've got some current coming out of this, and that's we're naming I1. They named R1. They didn't make that at all. Just 7 volts. You go into a junction here, and at this junction, I1 comes in. Later we'll see I3 comes in, so I2 must be going out. You can't have all 3 coming in, because we'll get to it in a second. That's the first of Kirchhoff's laws. Okay, that's called his junction law. And you have another current here, not the same as this or this. That's I2, and that's going through R2. And that would be in R2 that gave us his 2 ohm resistor. Okay, that goes to junction 2, so I2 goes in, I1 comes out, I3 comes out. We'll get to that in a minute. Down here you have an 8-volt battery, negative to positive, so it's 8 volts in this direction. It produces a current I3, and that goes through R3, which happens to be 4 ohm resistor. And it goes back up into junction 1, which comes through that as well. I2 comes out of it as 1. So, first, the junction law, okay? All the currents going into a junction must equal the amount of current going out of a junction. So in other words, the total current through a junction has to be 0. So here we have I1 coming in, the direction we chose up there, I3, the direction we chose based on that battery, going here. That means I2 must be coming out. So we say that I1 coming in, minus I2 because it's going out, plus I3 because it's going in, that has to equal 0. The sum of the currents into and out of a junction has to be 0. Now, if we went to junction 2, you see the same thing, only then it's minus I1 plus I2 minus I3 is 0. That's the same equation, it's just the opposite of it. So it's not a new equation. So you can only use the one junction here in this setup. So we've got three unknowns and three currents. That's what we're looking for. They gave us the voltages and the resistors. So now we've got to deal with what they call the loop laws. Or at least,
That's what I was thinking, yeah, Kirchhoff's loop laws.
yeah.
I thought those only applied with the capacitor.
What's that?
I thought Kirchhoff's loop laws applied with a capacitor.
Well, it could.
We have two, yeah,
Yeah,
because
but
there's
we
multiple
just don't have it.
voltage sources, we're going to have looping here.
So this one, the loop law, or that's what I call it, circuit law. They could name it something else. Well, maybe they don't name it. But this is the second one.
Loop law is like the charging and discharging cycles of a capacitor.
Yeah. Well, I mean that may. Okay. I didn't say everybody called it loop law. That's why I call them Kirchhoff's. Because you go around the loop.
That's kind of, it looks exactly like the diagram you have for a loop law.
Yeah. And what it says here is this total voltage through a complete loop. Any loop has to be zero. Okay? So this is a +7. But rather than doing it that way, let's have the positive voltage on the right, the knowns, and then have the voltage drops on the left. This is the supply, this is the drop. So here we have a drop.
So the sum of
The sum of the drops has to
drops
equal the
has
sum
to
of
be,
the
yeah.
supply, right? It would be zero, okay? So let's start right here. That's why I started here and say, okay, and by the way, it was written on the previous slide, that IR is V, okay? Have you hit that far in Ohm's law yet? Have you hit LV? No, Ohm's law. Have you hit IV is equal to R? I mean, IR is equal to V. I'm sorry, I said that. Yeah, okay. That's, okay. So IR is equal to V. That's your voltage drop here. 3 times I1. And then go around the loop here. We chose the direction of the loop the way we thought it would be going. The current would be flowing here. I think it's the only way it could. So 3 times I1 plus 2 times I2. Those are your voltage drops. And then your voltage supply is 7. Then do the loop down here. This time I'm going to choose it going this way because that's the positive voltage is this way. So you first have a drop here of 4 I3 plus 2 I2 is equal to 8. That's the voltage supply. So that sets up our three equations. Now I said before, this was before you came in too, I said you could have chosen a loop around here. That would have been a little messy, but that's a loop, okay? Then it would have been a +8 volts, a drop here, and if you assume your current's flowing this, no, but we've already assumed the current's flowing this way, so that would have been...
Wouldn't the current be inflowing in the direction of the greater voltage though?
Yeah, so, but we don't know, because we have some going this way. So the way we've drawn it, that would be, you're going against the drop, so that would have been a plus, and then this would have been a minus, because you're going against the plus, you know, as you circle that. That would have been messy and easy to make some sign errors. These two are much cleaner. So we only need 2 more equations. Because we've got 3 unknowns, you only need 3 equations.
So what was the foundation of the original equal 0 equation again?
Oh, that's the current. The current
Oh, the
is
sum of all the currents.
Yeah, the sum of all the currents. That's the junction law, is what I call it.
Yeah.
That I1 minus I2 plus I3 is equal to 0.
Okay.
Because I1's coming in, I3's coming in, and I2's going out. The way I've drawn it, which I think is the way it's got to be. So this is our 3 equations. I wrote that as a matrix, okay, and then I did 2 sleights of hand at once, okay. I noticed the 3rd equation here, those coefficients are all multiples of 2, so I divided by 2, but then I would rather have that up here where it belongs and move this one down. So I exchanged row 2 with 1/2 of row 3. So that's what I did here. So this is 1/2 of row 3, and this is row 2 now. Row 3 was the old row 2. Okay, then the next thing, we wanted this to be a 0, and we did that by -3 R1 plus R3. R plus R3, -3 R1. Row 1. Now these aren't resistors, okay? So I've got too many R1s and 2s here. This is rows now. These are matrices. Divorce it from this. Okay. and that gives you, that would make a 0 here. That's where Muhammad came in, and I stopped right there and haven't gotten back to it. So using this one right here, minus 3 times row 1 plus row 3, that gave us 0 here. Do the next one.
6.
Really?
Yeah, negative 3 minus 3 minus 1 give us, 5.
5. Okay, good. All right, 5. All right. This would be a 5. All right, next.
0.
Second.
So minus 2.
Negative 3. Okay, and last. Second.
4.
No. Okay.
I'm sorry, you multiply. It's going to
Okay.
be 7. It's going to be 7.
7, exactly.
Yes,
7.
it's
Okay.
multiply.
Right.
Because it's minus 3 times 3, negative 3 times row 1, 3 times 0, then 0. And then
Plus 7.
divided to row 7. Row.
Yeah. Minus 3, row 1 plus row 3.
Okay, plus 1.
Yeah, good. That's the one you're changing. All right. Now, what do we want to happen next? Now, here we come again. I'll check with my consultant. Do we want to do Gauss elimination or Gauss-Jordan elimination? Gauss elimination comes with back substitution. Gauss-Jordan elimination, you eliminate substitution, back substitution. Which one you want to do? I don't care really much.
Go with Gauss.
Gauss with back substitution? Okay. All right. So what do we want to happen next? The 5 becomes 0. How do we make that happen?
Multiply by 1.
Yeah, row 2 by
By 5.
negative 5 and row 3. So negative 5 row 2 plus row 3. Last time I was writing row 3 minus row 5 row 2, and someone didn't like it, so we changed back. Okay. Yeah, who was that? Okay. All right. So doing that, what do we get? Top row stays alone. It's the same. 1 minus 1, 1, 0. Oh, I forgot. At the end of the last class, we had just got started on a analysis of a network, but we didn't have time to finish it. And y'all begged me to let you finish it at home, that we didn't need to do it over class. So did y'all, did it come out okay? I'm sure it did. Okay. Did you need to go back and, yeah, let's not. Okay. All right. Good. All right. So let's continue here. We'll write down row 2 also because we're using that. And it has its leading 1, and it disappeared. 2, 4. Now, operating on row 3, what does it become? 0, 0. Like negative 13, right? Okay. And?
No. 13. 14.
One more time.
5 times 4, that negative 20.
Right.
Yeah, minus 13.
Negative 13. Okay. Okay, the debate rages on. Okay. Now, what would you do next?
Divide everything by 13.
Yes, divide everything in the last row by negative 13, and that will give you a 1, 1. Which tells you what? The third column stands for I3, and so that tells you I3 is equal to 1 amp. If the others are in volts and ohms, then this will be in amps. Okay, what do we do with that? Back substitute. Since our consultant wanted to do it, what would that give us? Yeah. I2 plus 2, I3 equal 4. That's exactly what it tells you. But we know what I3 is. It's 1. So this is I2 plus 2 equal 4. So what would I2 be? 2 amps. Okay? And now we go to the first row, and that tells you what? I1 minus I2 plus I3 equals 0. But we know what I2 is. It's 2, so that's minus 2 plus 1 equals 0. So that tells us that I1 is equal to, I1 minus 1, if you were doing it that way. Let me. I1 minus 1 equals 0, so that tells us I1 is also equal to 1 amp. Perfect. Okay. Certainly 1 plus 1 makes 2. I1 plus I3 equals I2. That works. And you can go back and check your voltage drops, and I think you'll see that works as well. That's a 3-volt drop there, and a 2 times that is a 4-volt drop there. 3 and 4 add to 7. And down here you have a 1, so that would be a 4-volt drop there, plus 4-volt drop. Yes. Good deal. That's how you do Kirchhoff's laws. Usually you can get more loops than you need, so take the easiest ones. Usually you'll get at least 1 junction, maybe 2, depends on how complicated your circuit is, but you'll never get enough just from the junctions, because at some point they start replicating each other. They're dependent on one another, so you don't get independent equations. So then you'll need some loop laws, is what I call them, and at that point choose just the ones you need, make the easiest ones that you can to fill out the number you need. Okay, does that make sense? And they got 1 amp, 2 amps, and 1 amp. Good for them. I'm so proud of them. All right. Now, if that wasn't enough for you, example 7 is another analysis of an electrical circuit. This one has 6 currents. Okay? Though they could be brought down to fewer than 6, but let's do it the way they suggest. Okay? And actually, I'm sorry I erased it. You could have gotten that down to just a 2 current system, because you know that I2 is I1 plus I3, so everything you were doing before you could have just, yeah, but never mind. But anyway, let's go with this. Guess I'll start at the corner here and go down till I hit a battery, and that's a 10-volt battery. Okay, it goes through a resistor, and this is a R1 is a 2 ohm resistor. Okay, now we have, leaving that battery, current 1, I1. Okay, then it runs along over here to a junction, and they name that junction 1. All right, let's go north from there and hit another resistor, and this is R2 is 4 ohms. Okay, and that we're going to call current 2 coming up this way. Okay, and it goes up to junction number 2. And this place we started from connects to 2. And from 2 to the right, we hit another battery, and that's a 17-volt battery. Okay, and just to the right of that, we hit another resistor. They're naming R4. So obviously we missed R3 somewhere, and this R4 is 2 ohms. Okay, before you get to junction 4. Well, down here, we named that current I4 coming out of that 17-volt battery. Well, down here at the bottom, just past junction 1, we hit another resistor here that they're naming R3, and R3 is a 1 ohm resistor. And they're saying this is, oh, I'm putting a direction to it, but I probably shouldn't. They actually put it the other way. So let me reverse that. Ah, God, Vince is here. And Vince, right at the end of the class, if you're hanging, I just got to ask you a question. Okay. All right. Now they're saying that this current, and I don't know if they're right or not. I'm just doing what they say. They're saying this current is flowing in this direction. That would be I3. I'll leave that, my opinion of that, until I see the rest of the circuit here. There's junction 3 there, and junction 3 connects with junction 4 through another resistor. This is calling I5, R5 I mean, and R5 is a 2 ohm resistor. Have you had physics yet? Okay. Then this may be new stuff to you. I'll try to explain something in a minute. Let me finish drawing this. And finally, here we come and hit another battery here with the plus side here and the minus side here. And that's a 14-volt resistor. I mean a battery. What's that? Battery. Oh, yeah. Duh.
I mean, batteries do have internal resistance.
Yeah, but not that much.
Not 14 ohms, though.
Yeah. That would be a hot battery. A very hot battery. Okay. And this will be our resistor 6 here, which they say is 4 ohms. And that current here had better be flowing in that direction. Yeah, it is. And this will be I6. I didn't show this one. I'm convinced this one's got to be flowing in that direction. That's what they do too. And that will be I5. Now let's see if I agree with 3. I'm not sure I agree that I3 is flowing that direction. It could be, but I'm guessing not.
It has to be because on the 12-volt battery, the circuit is going that direction.
Okay, this is a 17 volt.
That's the 17 volt.
Yeah.
So it's really going that direction.
Well, but the 14 volt would be pulling this way and the 10 volt pushing this way. So that's why I said they've got more resistance. So I don't know. I'm open to this being wrong, but it's okay if it's wrong. It'll all show up that it'll just show up as a negative current, and then we just say, oh, it's going on the wrong direction, so we'll turn it around.
I think it is the right direction because on junction 1, they're all coming in, and then they're going out towards
junction 1, this was coming in, that was coming in.
Right.
Yeah. So
there's only one outward path, and the other path puts you in the face of more voltage rather than less.
Yeah.
You have there's more voltage potential stacked on this side
Right.
of the junction than there is on top. So all the voltage should exit through the top. It has the least voltage potential. It's facing two negatives.
It could be. I mean, yeah, could be either way. But even if you label one wrong, then you'll come up with a minus current. Then you just know to turn it around. That's what I'm saying.
Yeah.
You don't have to be too bent out of shape with it yet, because if you do label one wrong, it'll come out. Okay. So we have 4 junctions. So let's see if we have 4 equations. We may or may not. At second.
I see 3 right now.
1, 2, 3, 4. I've numbered them. 1, 2, 3, 4. Okay. Okay. So it's only 3 voltages, but 4 junctions. Okay. Now, at junction 1, we have I1 coming in, so we'll make that positive, minus I2, because that's going out, plus I3, according to them. That will be coming in, so that's a plus, and this will be equal to 0. Because the sum of all the currents into or out of a junction is 0. I mean, you can't have a pileup of current there. Okay, let's go to junction 2. Okay, that has negative I1 plus I2 minus I4. And, oops, I put it in the wrong place. Minus I4, and that's equal to 0. When we go to junction 3, we have a minus I3 plus oops, wrong place. Plus I5 minus I6, it's leaving 3, minus I6 is equal to 0. And then at junction 4, I hardly have room for it here, but let's try it. I4 is coming in, I5 is going out, and I6 is coming in. And that's equal to 0. Okay, now, I can almost guarantee you there's some redundancy here. Not all of these are independent of one another, but there's a place to start. Guess what's going to happen if some of them are independent or dependent on one another? We're going to get a row of zeros. Okay? And that's okay. We'll just ignore them there. All right. Now, we need at least 2 more equations. But for safety, let's go with 3. That'll cover everything. And again, I think the interior loops is what I would prefer. And I will draw this loop going in this direction, draw this loop going in that direction, and draw this loop going in that direction. And this would indicate our I3 probably is going in the right direction down there, but let's see. So I'm going to start just south of the battery here and have a drop of 2I1. Okay, and continuing the loop, and that's going to be another drop of 4I2, and then you get back to here, that's equal to 10. Okay, over here, this one I'm going to start right here and do a 2I4. That's the voltage drop. Another one here, 5I5. No, I'm sorry, I can't read. 2I5. Okay. Plus I3. Okay, because that's 1 ohm. And that's equal to 17. Alright, going to my third loop over there, we'll start right anywhere here. First thing we hit is 2I5 plus 4I6. And that's equal to 14. Okay, voltage drops equal voltage supply. Okay. The total voltage through a loop has to be 0. Okay. Now, this is such a mess. I'm afraid I'm going to have to erase my drawing because I got to put my matrix somewhere. But if y'all got the drawing, it's in the book, it's everywhere, and hopefully I haven't messed up anything. So let me erase it, and that's where we'll start with our matrices. The other reason I like doing the 3 interior loops, you only had 1 battery in each loop. So you had some number there, and we weren't arguing about what that needed to be. Okay, so we got 7 equations with 6 unknowns. Like I said, I can basically guarantee you one. I can't guarantee you one of those is unnecessary. Okay, so the first equation we have here is 1, negative 1, 1, 0, 0, 0, 0. 3 for the 3 currents and 1 for the, yeah. Okay, second one, negative 1, 1, 0, negative 1, 0, 0, 0. Okay, next one. 0, 0, negative 1, 0, 1, minus 1, 0. Next one. 0, 0, 0, 1, negative 1, 1, 0. Okay. It's going to take some room here, won't it? Okay. All right. Now, let's start with the next one. 2, 4, 0, 0, 0, 0, 10. Okay, next one. 0, 0, 1. I didn't put my plus sign in there, did I? Okay. 2, 2, 0, 17. And the last one. 0, 0, 0, 0, 2, 4, 14. Okay. Now I'm going to do 2 things right off the top. One, I'm going to take row 5 here and divide by 2. And I'm going to do the same thing to row 7. Okay, is that okay? Just eliminate. So that's going to be 1, 2, 4 zeros and a 5. Okay, 1, 2, 4 zeros and a 5. 1, 2, 4 zeros and a 5. Going to do the same thing to the last row. That's going to give me 4 zeros, 1, 2, and a 7. 4 zeros, 1, 2, and 7. If I can reduce the numbers as much as possible, I will. Okay. Everything else, I don't think there's anything else we can do to simplify. Now, where do we begin? And this is rather ugly, so let me... Oh, it didn't work. Okay. That was a 1 there. It looked like some weird thing. Okay. All right, you got 1 where you want it, and what do you want after that? Yeah, you want 0 there and there, so this will be row 1 plus row 2, and this will be minus row 1 plus row whatever, 5. Okay. All right, so row 1 stays the same. 1 minus 1, 1, and 4 zeros. 1, 2, 3, and 4. Feel like an exercise guru. Okay, when you add those two together, what do you get? 0, 0, and 1, negative 1, 0, 0, 0. All right. And then we'll copy down the next two rows. This is what makes this so much fun. You spend a lot of time just repeating and repeating. Okay, copy this one too. 0, 0, 0. 1 minus 1, 1, 0. And that'll be a 0. 3. Negative 1. Yep, that's a 0. A 0. 0. 5. All right. And then copy down the next two rows. 0, 0, 1, 2, 2, 0, 17. And a 0, 0, 0, 0, 1, 2, and 7. All right, now I've got to erase my bottom row, and I'm hoping everything's okay with that. What's that? You just go back and forth at the top?
Yeah.
Okay, we can do that. So, I've still got to erase, sorry. Okay, so we'll erase this. Well, I thought I'd be erasing it. I guess it didn't erase it. Let's try it again. Okay. And let's not erase more than we have to. The top row stays the same. This one will change. I think that one stays the same. That one stays the same. This one will certainly change. And for now, those two will stay. We may change. Okay. So what do we want to happen next? Oh, boo, yes. We got to introduce some fractions, don't we? Because the next thing we want is a leading one in column 2. We don't have a leading one in column 2 until you get here, and that's not a 1, it's a 3. So what we're going to have to do is divide this row by 3, which is really messy, but doable. Okay, so I'm just going to do that in place. Okay, so in place, this will be a 1, negative 1/3, and 5/3. Oh, where did that go? Okay, that was close. Okay, a 1, negative 1/3, and 5/3. A 1, negative 1/3, and 5/3. Boo hiss. Okay, but the good news is that becomes my new row 2. So that's a 0, 1, negative 1/3, 0, 0, 0, 5/3.
So do you want to copy down row 2 to that row at the bottom then?
Yeah, and the row 2 goes down here, and that'll be a 0, 0, 1, minus 1, 0, 0, 0. Okay. Now, what's the next thing you want to happen? You want that to be a positive one. So the two things we could do, we could swap, but that's going to be more work. Let's just do plus, minus, plus. That's pretty easy, right? Multiply row 3 by minus 1, making plus, minus, plus. I can do that, okay? Just wait, yeah, let me. It was. Okay, now, I guess at some point here we need to check with our consultant to see if we're doing Gauss elimination or Gauss Jordan. Gauss? Okay. We're going to go with Gauss because we should have already done something else if we weren't, but we're fine. Okay, so we got row 1, fine, row 2, fine, row 3, okay, we got 2 things to change there. Now, I almost wish we would have left the minus sign in there to do it, but it's still easy to do. So what do we do here?
Row 3, negative 1, row 3.
Okay, negative row 3 plus, what is it, 5, row 5, and negative row 3 plus row 6. Okay, now I got to be careful over here because I've moved some things around. So my row 2 has changed. Okay. Okay. My row 3 has changed signs. So let me go back and just do that quickly. Plus, minus, plus. Okay. Row 4 stays the same. And we're changing rows 5 and 6. So we lose those. I'm going to hold off what they're going to be. Okay. And I think row 7 stays the same. Okay. So we're all right for now. So let's do a new row 2 is a negative 1/3 here, a 0 here, and a 5/3 here. Okay, it'll come back, I hope. Okay. Our new row 5. What will it be now? 0, I got it. Got it. Got it. I think I'm going to have to move some more changing. Okay. I've been listening to you and I've been thinking myself. Let me make sure I'm with you on it. Woo! For some reason that went off. It's not projecting well. This is a minus row 3 plus row 5. So that's a 0. And that's a what? Minus 1? Is that right?
Yes, it is.
Yeah. And the next is going to be a plus 1, right?
No. It's going to be a negative 1 again. Oh, yes, plus 1.
Okay. And the next is going to be a minus 1, right? And the next is going to be a 0. Buy that?
Yes.
Okay. And then row 6?
0, 0, 0.
0, 0, 0. I'll buy that one.
2.
2. 3. Negative 1.
And
17. All right. Any bells, alarms go off?
That's it, almost there.
These two are the same rows, they just differ by a minus sign. So that's the one we lose. Okay? So I'm just going to erase it. Is that okay?
Erase both of them?
No, just this. Because they're basically the same row. Right? So now I'm going down from 7 to 6, which is what we needed. We needed 6. Because we had 6 unknowns, we need 6 equations. We just didn't know which ones. This is going to lose this one. Technically, add those 2 rows together and this becomes a row of zeros. I'll put that at the bottom and then don't write it anymore. Well, too bad. It's gone. Never to be seen again. Okay.
It was zeros. It was easy.
All right. Now, what's the next thing we want to happen? Let's review. We got a 1 there, 0 below it. a leading one in row 2, 0 is below it, a leading one in row 3, 0 is below it, a leading one in row 4, but we need that to become a 0. So how do we make that happen? No, that makes it a 1. We want it to become a 0.
Oh, you want it to be 0, not 1.
Right.
So
No, not 2. You see, you want the leading one there, and you want a 0 below it.
So that one is going to be 2.
Multiply the leading one here by the opposite of this, and add it to it, right? And that will give you a 0. And then we got zeros below it already, so we're fine. So now let's figure out what to do over here with the minimal amount of work. Be as lazy as possible here, okay? Row 1 stays the same, row 2 stays the same, row 3 stays the same, row 4 stays the same. What's that?
What we just erased the other row? You write it right there.
Yeah, that's what, yeah, got it. We're on the same page, I think. Okay? So, minus row 4 plus row 5. What does that give us?
0.
0, 0, 0. It's minus 2 row 5. Yeah, that's a 0, row 4, all right?
I did 4.
Huh?
I did 4. You did the rest.
I couldn't hear.
I did 4 of them. You did the rest. I did 0, 0, 0, 0. So you
Yeah.
did the rest of it.
Oh, I see. Fair, huh? Okay. I don't want to go into business with him. Okay.
It's going to be 2 minus almost.
It'll be what? No.
Minus 2 times minus 1 is
Minus
positive 2, plus 3 is
5.
5. Good.
And we get minus 3. Yes.
Okay.
And then we got 17.
We can't get rid of that 17, can we? Okay. So let's erase.
Multiply it by 0.
What's that?
You can
We,
multiply it by 0.
we could. Okay, I'm going to erase both of these because I know.
Favorite multiplication now.
Okay. Now all we do is write down the last row. 0, 0, 0, 0, 1, 2, and 7. All right. What's the next thing we want to happen? We got a 1 with zeros below it, another 1 with zeros below it, another 1 with zeros below it, another 1 with zeros below it. What do we want next?
B1, now 5 to B1.
Yes, but I don't want to divide by 5, okay?
So we can swap the.
Yeah, I want to swap those two rows. Okay? So I guess that's what we'll do next.
Just erase the 5 and replace it by 1.
Okay? All right, can you remember? Let's just do it here. Okay.
Yes,
It'll be safer.
I got it noted.
You got it covered. Famous last words. Okay. Okay, let me get this out of the way. I know we need to get rid of that. Okay. Those first 4 rows are the same. Let's just bring this one up here and then rewrite the next one. Okay? So we're going to erase this one and bring that row up so I can look at the other one and do it. Erase those. And this will be 0, 0, 0, 0, 1, 2, 7. And that one we don't like so much, 0, 0, 0, 0, 5, negative 3, 17.
So we want 0 on that 5.
Yes, and how do we do that?
Multiply. Negative 3, no, negative 5 row 4.
Row 5, I think it is, yeah.
Row 5. Row 6.
Okay. So, all right. Other rows stay the same. Oh, I didn't need to erase those. Okay. All right. This is a 0, 0, 0, 0, 1, 2, 7. And then do the operation you said. 0, 0, 0, 0, 0.
It's going to be -10 minus 3 and -13.
They like negative 13s, don't they? Okay.
And then 5, 7, 37. -37 minus 17 is going to be 10. 20.
Okay, negative 35 plus 17, I think is,
Oh, 35. I said 37.
I know.
I'm liking the easy 7. That's why I was like, get it out the other 7.
Yeah.
It's going to be 18.
Negative 18. Right?
Yes.
That's nasty. You know, they didn't wind up, okay, let me just check. Yeah, I have a feeling we made an error somewhere. And I can't see where it is. But we got a lot of them right. But, well, let's see, yeah. You know how they did it? Using Gauss-Jordan elimination, a graphing utility, or a software program, solve the system to get blah. So they just did it that way. Just said that's what it comes out to be. But let's see what the currents are. 1, 2, 1, 1, 3, and 2. So this was a mess up here. I don't think we wound up with fractions. I don't think we did. It could have. And this one I know is a mess. So we did make an error somewhere. I just haven't figured out where. And I'm not going to go back and find it. But you see the process. Just don't make the error. Okay. Those are your walking papers. And that finishes 1-3 finally. So homework exercises here. Do as many of the polynomial curve fittings, odd numbers 1 through 11 that you choose. Then you can do any of odd numbers 13 through 13 or 15. Then try to do either 17, 19, either of those that you'd like to do. And then there's a guided proof, which they're going to guide you through, so it's not too bad. And then there's a calculus problem that we really didn't do any like, but you can try that if you'd like. Then there's another curve fitting 25 if you want to try that one. But then we get into the network analysis, which was like we did last time, 27 or 29, you choose. And then, well, yeah, for Kirchhoff's laws, you can do either 31, 33. Now there's another one that we didn't do one like, 35. You could do that one. 37, that's a partial fraction decomposition, which is pretty good. And if you want to try a Lagrange multiplier, you can do that. Okay. Then there's a bunch of review exercises. If you haven't had enough to do, odd numbers here are in the back. And you can do any of the odds 1 through 5, 7, any of the odds 9 through 19, 21, 23, 25 or 27, any of the odds 29 to 37, either 39 or 41, and any of the odds, or either 43 or 45, any of the odds 47 to 49, either 47 or 49. 51s are writing. You can do that if you or at least think through it. 53 is a little more complicated, but it's probably not too bad. True false 55. Then you have 57 is a possibility, 59 is a possibility, 61 is a possibility, and then you have either sales or deer population 63 or 65, or vertical, or okay, and then network analysis is 67, and that'll be it. So before you go, I have a gift for you. that finishes chapter 1. Finally, so here's your test. Chapter 1. Get back on events while you're on the way. Go ahead and want to get your L. Right. So one person absent. Is that all? Nope, 2 people absent. I hope I have another one somewhere in here. What's that? Oh, there's the other one. Okay. What's that? I'm sorry, something copied through. That's, ignore the pale stuff. That's just, that was on the back side or messed up somehow. Okay, sorry that we ran. Did we run a little over?
A little bit. We're good.
No extra charge. Okay.
Yeah. Just about like 8 times.
That's what?
Just a few minutes.
Okay. We will begin next time in chapter 2. I've got to end this one.